Hello, and welcome to this 7-week course in learning how to create your own websites. You may ask if it's possible to learn all this in just 7 weeks? Absolutely. My name is Esty, and I will be with you every step of the way. The development of software programs over the last 2 decades has made the design of websites so much easier and accessible. Where it once was a profession reserved for information scientists, it has developed into a new profession for creatives. The course is separated into units, making it easy to achieve success. By the end of the 7th week, you will be able to create static websites for yourself or professionally for clients. Take note that this course is intended for people who want to design their own websites but have limited knowledge of the internet, its technologies and software. It is a foundation program intended to teach key aspects of website building. Once you have these under your belt, you can build upon that knowledge to create more complex websites. Making websites are much easier than you think. Let's begin. Before we dive into website design, let's look at the platform where your websites will be hosted, the Internet. It is enriching to have a basic understanding of what the Internet is to assist you in choosing a hosting provider and for some basic troubleshooting. Although to some it might feel like the Internet has been around forever, it's still a new type of technology. In fact, the commercial part of the Internet we use, the World Wide Web, has only been around since 1991. When you look at what your friends were up to on Facebook, when you tweet, when you use Snapchat, send an email, or search for information on Google, you're using the Internet. In 1996, John Perry Barlow wrote a declaration of the cyberspace in reaction to President Bill Clinton's Communication Decency Act of 1996. Saying that the Internet is a separate global place without the physical boundaries that define states and give them their power. Cyberspace is something that happens independently of the physical world in exactly the same way as the mind and the body. It depends on the physical world and can't exist without it. But to a fairly large extent, it's another thing, unprecedented in world history, an environment where people across the planet could come together and have a sense of political constituency. What is clear is that the Internet Barlow described in 1996 looks vastly different than the one that exists today. The number of Internet users worldwide has grown exponentially and now represents about 40% of the global population. Then, English constituted the vast majority of content. Today, it's just one language of many. 2 decades ago, users dialed up for bandwidth of around 30 kilobytes per second. Now it is measured in gigabytes. At the same time, we've replaced the dominance of telecom operators with the dominance of web platforms like Google and Facebook. And where people once felt the Internet was this separate place, it has now become interchangeable with reality. As I mentioned, around 40% of the world population has an Internet connection today. In 1995, it was less than 1%. The number of Internet users has increased tenfold from 1999 to 2013. The first billion Internet users was reached in 2005, the second billion in 2010, the third billion in 2014. As you can see, the use of the Internet has grown exponentially in the last 16 years, and that number is expected to increase in the future. The reason for its rapid expansion is due to the introduction of the smartphone. Smartphones are more than just mobile phones. They can access the Internet and can run a variety of third-party software components, otherwise known as applications or apps for short. We won't focus on app design in this course, but it is important to understand that the Internet can be accessed from multiple devices, from personal computers or PCs to laptops, tablets, and smartphones. Let's look at what will be discussed in this unit. Firstly, we'll ask, what is the Internet? How is it defined? Then follows a brief history of its origins, and lastly, we'll see how the Internet works. So, what is the Internet? According to the Federal Networking Council, or FNC's resolution of 1995, the term Internet refers to the global information system that 1. Is logically linked together by a globally unique address space based on the Internet Protocol or its subsequent extensions and/or follow-ons. 2. Is able to support communications using the Transmission Control Protocol, Internet Protocol, or TCPIP suite, or its subsequent extensions and/or follow-ons, and/or other IP-compatible protocols. And thirdly, it provides, uses, or makes accessible, either publicly or privately, high-level services layered on the communications and related infrastructure. In less technical terms, the Internet is a global communication system comprising of a vast computer network linking smaller computer networks worldwide. The Internet includes commercial, educational, governmental, and other networks, all of which use the same set of communication protocols. The origin of the Internet is far earlier than its commercial use, and actually have its origins during the Cold War. History changed on October 4, 1957, when the Soviet Union successfully launched Sputnik 1. The world's first artificial satellite was about the size of a beach ball and weighed only 83.6 kilograms or 183.9 pounds and took about 98 minutes to orbit the Earth on its elliptical path. While the Sputnik launch was a single event, it marked the start of the space age and the US-USSR space race. That launch ushered in new political, military, technological, and scientific developments. The Sputnik launch changed everything. As a technical achievement, Sputnik caught the world's attention and the American public off guard. The public feared that the Soviets' ability to launch satellites also translated into the capability to launch ballistic missiles that could carry nuclear weapons from Europe to the US. It also created the fear that such a missile can destroy all communication lines on US soil. The earliest ideas for a computer network intended to allow general communications among computer users were formulated by a computer scientist named J.C.R. Licklider in 1963 with his concept of the intergalactic computer network. It contained many of the features of the contemporary Internet. His idea formed the foundation for a research project funded by the Defense Department's Advanced Research Projects Agency, or ARPA for short, with a goal of creating a means of communication besides telephone lines. The first network was called ARPAnet. The focus was on continued communication in the event when part of the network was disabled. ARPAnet was limited in function but sparked a concept of a different method of communicating. ARPA's Larry Roberts proposed a design in which information transmitted over the network would be broken up into small chunks called packets that could be sent over multiple paths to a single destination, where they would be reassembled in the proper sequence. If one portion of the network were disabled, packets would simply be routed through a different portion of the network. This scheme would make the network very resistant to attack. In 1968, research development on ARPAnet gained momentum. a communication system was designed that connected small sets of computers across various universities, known as Interface Message Processors, or IMPS, to serve as connection points to the ARPANET. Various mainframes and mini-computers on each respective campus were connected to the IMPs. The IMPs provided access from their site to other sites. These interconnected computers led to the growth of more such computers on other campuses and research facilities across Northern America. During the 1970s, new protocols were added to enable new types of data communication on ARPANET. By 1983, an entire suite of protocols, collectively known as TCPIP, was made the standard for data communications on the network. By 1985, companies such as IBM and MCI became involved to create a high-speed transmission backbone, or main communication line for the Internet. Maintaining the Internet was expensive. The government informed the regional networks who maintained the backbone to become self-sustaining. The pressure to support themselves without government assistance led to the opening of the Internet in 1991 to commercial Internet access providers. If your computer wanted to successfully connect to the Internet, all it needed was to be able to support TCP/IP and a protocol called HTTP, Hypertext Transfer Protocol. But the commercial Internet still lacked a crucial program that we take for granted today. What do you do when you search for something on the Internet? Like a list of hotels for an overnight stay during your trip? Or you vaguely remember the name of a company, but you don't know their website address off by heart? You'd probably Google it, right? Or use a similar program like Mozilla Firefox, Safari, or Opera. These programs are known as web browsers. Web browsers simplify the search process. And we have Berners-Lee to thank for making the Internet user-friendly. Tim Berners-Lee proposed a global hypertext space that would provide a system for linking together the many different documents that were already scattered across the Internet. He wanted to link information on the Internet much in the same way that the human brain works. He developed a program called the World Wide Web. It was a prototypical HTML-type authoring tool. He also developed a web server along with his colleague Nicolas Pelot, who developed a command-line web browser which could run on a variety of different computers. Finally, the World Wide Web was born. Point and click. So much easier than surfing. In this section, we are going to look at how the various computers across the world communicate with one another on the Internet, and specifically how your computer receives information. In the previous section, I mentioned Robert's invention of packet switching. This really set the development of the Internet in motion and is essential for all information to be sent along the Internet. Packet switching is the dominant basis for data communications worldwide. Prior to the advent of packet switching, both voice and data communications had been based on the idea of circuit switching, as in the traditional telephone circuit, wherein each telephone call is allocated a dedicated end-to-end electronic connection between the two communicating stations. Such stations might be telephones or computers. The temporarily dedicated line typically comprises many intermediary lines which are assembled into a chain that stretches all the way from the originating station to the destination station. With packet switching, a data system could use a single communication link to communicate with more than one machine by collecting data into datagrams and transmitting these as packets onto the attached network link as soon as the link becomes idle. Thus, not only can the link be shared, much as a single post box can be used to post letters to different destinations, but each packet can be routed independent of other packets. Does this sound somewhat too technical? Let's make it easier by using a metaphor. Circuit switching, used by traditional communication lines such as telephones, is like a train riding along train tracks, whereas packet switching, used for the internet, is like cars driving on the highway. A train carries its train carts, the data, in a set order and rides along a track, the dedicated line that takes it from point A to point B. Other trains can't use that track at the same time as the first train, otherwise it will crash. Packet switching is like cars driving on a highway. The information is broken up into smaller pieces or packets. These packets of information are now sent to point B using cars. Multiple cars carrying the data packets can drive on the same highway, the line or channel at the same time. There's no set order and the cars can change lanes at any time. Ultimately, all of those cars arrive at point B, but possibly at different times. With packet switching, the cars analogy, travel is more efficient in the sense that one highway can accommodate multiple travelers. What's more, if one lane on the highway happens to close, the car simply moves over to another lane. The disadvantages of the packet switching system is traffic. If too many cars or data packets get on the same highway, the channel, those cars will move more slowly and may eventually stop. To increase the speed of your internet connection, you need more lanes on the highway, which we call bandwidth. No wonder the internet is also known as the information superhighway. As I mentioned before, the internet is made up of thousands of smaller networks with no central point of control. Hence its name, internetwork, meaning a network of networks. Each of these networks has at least one specially configured computer called a router or gateway that examines each packet or chunk of information that is passed to it and determines where to send it next. To enable the many smaller networks to work together, every computer that communicates across those networks must follow certain rules. These rules, called protocols, are like a common language. Protocols enable one computer to share data with another computer anywhere on the internet, just as two people who speak the same language can share information through conversation. There are many protocols that dictate how computers share information on the internet. To access the internet, computers use special software. It is known by various names, including protocol stacks, network drivers, and network components. Protocol stacks give computers the knowledge how to access the internet according to the established internet protocols, whereas protocols define the language or rules by which computers communicate. Protocol stacks are the software that enables computers to follow the rules and thus to communicate. The two most important protocols for communicating on the internet are Transport Control Protocol, or TCP, and Internet Protocol, or IP. TCP is responsible for dividing data into packets at one end of a transmission and reassembling those packets at the other end. IP, in comparison, is responsible for the formatting and addressing of the data packets being sent. That's why each host computer on the internet needs an IP address, a unique numerical label that distinguishes one host from another. Without IP addresses, data packets wouldn't be able to get to their proper destinations. When implemented together, TCP/IP is the communication language of the internet, and it was the key to making the internet a truly worldwide network. Modern TCP/IP networks use 4 distinct layers in order to transmit data, and that data always moves from one layer to the next. First, there's the application layer, which is responsible for interfacing with computer applications, such as web browsers and email clients. Secondly, there's the transport layer. This layer is where the transmission control protocol goes to work dividing data into packets, and on the receiving end, it reassembles that data. Thirdly, we have the internet layer, where the internet protocol assigns address information and determines the route the data will take. And finally, we have the network layer, wherein physical hardware actually carries the data via wire, fiber, or radio. When we send data across the internet, that data goes through each of these 4 layers in sequence, starting with the application layer. On the receiving end, however, the sequence is reversed. The data you send arrives via the network layer. It then goes through the internet layer to confirm it's in the right place. Transport layer reassembles all of the data packets, and finally, it reaches the application layer, and a recipient is able to view the data in an application. Let me make this quick simile. Sending data across a TCP/IP network is like sending a letter through the mail via the postal service. In the application layer, you're writing the actual letter that you're going to send. In the transport layer, you're packaging that letter in an envelope. In the internet layer, you're writing the address of the recipient on the envelope as well as your return address. And finally, in the network layer, you're putting the letter in the mail so postal workers can deliver it. While we often use the terms internet and web interchangeably, the reality is that the web is part of the internet but not the whole internet. The web is a collection of all the public websites on the internet. Remember Berners-Lee, who invented the World Wide Web? He was on a quest to create a more useful internet. An internet that wasn't simply a network for sending and receiving data, but a web of data that anyone on the internet could retrieve. In order to accomplish this, he needed to develop 3 essential pieces of technology, which are HTML, Hypertext Markup Language. This is the standard protocol for publishing content on the web. It's used to format text and multimedia documents as well as link documents with each other. URI, Uniform Resource Identifier. Just like every computer on the internet gets a unique identifier in the form of an IP address, so every resource on the World Wide Web gets a unique identifier in the form of a URI. The most common type of URI is the Uniform Resource Locator, or URL, also known as the web address. And thirdly, HTTP, Hypertext Transfer Protocol. HTTP is responsible for requesting and transmitting web pages. When you enter a URL into a web browser, you're actually initiating a HTTP command to go find and retrieve the web page specified by that URL. In relation to its TCP/IP network, HTTP is part of the application layer, as specific applications, namely web browsers and web servers, use HTTP to communicate with one another. Congratulations! You have completed Unit 1. We've taken a journey through history to understand what the internet is and how it functions. We've seen that the launch of the first satellite, Sputnik 1, set events in motion for the research project of ARPANET, the precursor to the internet. Many scientists and researchers contributed to the technologies and programs that eventually led to the internet. Notable developments are packet switching, TCP/IP protocols, and the web browser. Then we looked at how data is sent across the network. We used the analogy of cars driving on a highway to explain packet switching. We've also mentioned the protocols needed for computers to speak the same language. Feel free to watch this unit again to review more details. I'll see you in Unit 2.